All right. It says sections 4.1 through 4.5 that corresponds to your book. The first question is this section that wants you to do these without a calculator. There may be there is a section. You'll have a few problems there that you'll ask to not use a calculator on. This first problem is the log of 1/100. A couple of questions here I want to make sure we get answered. We understand. What is the default base? There's no base listed. 10. If I did square root, cube root, fourth root, I got to put a 3, a 4, a 5. If I just put a square root symbol, it's square root. It's 2. The base is 2. Excuse me, the base is really 1/2. So here in this, when this here is written like this is log base 10 of 1/10. Guys, these are kind of weird because they don't set up equal to anything. Remember, the way this goes, it goes log base of the answer gives me an exponent. Several months ago, whenever it was we first started, I put a slideshow up here, and it says all logarithms are, had logarithms in the middle. Logarithms are just exponents. That's all they are. So I've spent all my time trying to get you to understand that this said 10 to the x equals 1/100. Now let me talk to you. Let me talk to you real quick about making sure that you understand what's happening here. 10 to the x equals 100. Guys, whoever made the problem, I chose 1/100 and not 1/101. Not 1/102, 1/110. I chose 1/100. The reason I chose 1/100 is because I can make 1/100 some power of 10. How do I get 100? What do I do with 10 to get 100? 10 times 10. So that's 10 squared. How do I move it to the bottom? So 1/100 is really 10 to the negative second. And that's what I'm trying to get you to see, and I don't think we got this concept when we were going through the regular class. Guys, I'm not going to ask you to paper and pencil find the log of 10 to the 1/32. Log base 10 of 1/14. So remember that 10 isn't something a factor of. It's going to have to be a specific number so that now I have the bases the same. So I drop my bases, and like she said, x equals -2. Now, just to make sure we understand how it's going on, your calculator may be sitting right there beside you. Real quick, do log of 1/100. How would you write 1/100 with your calculator? 1/01, or you could go 0.01, couldn't you? Either way, log of 1/100 divided by log of 10, or just put log of 1/100 because this is base 10. Hit enter, and bang, you should see -2. Yes?
Yes, sir.
Yes.
Make sure that happens and you keep up with your parentheses and everything. All right, number 2. Log, this time the base is changed. Log base 2 of 32. Okay, if logs are exponents, if the log base 2, then that means you're trying to find out what causes 2, what power it is that gives you 32. Again, understand I asked you 32. And the thing that's significant about 32, watch, 2 times 2 is 4, times 2 is 8, times 2 is 16, times 2 is 32. I didn't say 2 to the x equals 33. I'm wanting you to solve these without a calculator. So if you're going to solve them without a calculator, you have to change that 32 to 5, 2 to the 5th. But how'd you know that? Not math magic. I looked at my hint. My hint in this problem is that there was a 2 in there. So I said, the 2 must go into it. 4, 8, 16, 32. Drop the 2's, x is 5. Number three, I don't know what it is that they're trying to, how this problem got kind of snuck in there with stuff. But anyway, let's look here. We got 4e to the negative 2 to the negative 3x. Isn't it a negative 3x? So when you raise a power to a power, you multiply the exponents. So that ends up giving me 4 to the negative 3x on bottom. So where's that, or on top? So where's that going? Bottom. So 4 to the negative 3x on bottom, and e to the negative negative times negative is a positive 6x. Oh, wait a minute now. If this negative moves down, what does it become? Yeah, my bad. I guess I could say 4 to the third is 64. I could say 64x. 64. Last one.
We would do natural log.
No.
You wouldn't change
No.
the natural log.
Not unless it's asking you what the natural log of something is. No, you wouldn't want to change it to natural log. It is a good thought, though. I like the fact that you connected those two. Log base 5 of, goodness, what a tough problem. Log base 5 of 0.04. Hold on a second now. Again, follow the logic now. The 0.04 was chosen on purpose. 0.04 was chosen and not 0.06 or 0.10 or 0 whatever. 0.04 was chosen because my 6th grade teacher, Miss Gwen, was in 6th grade, Knoxville, Tennessee. Miss Gwen said 4. How do you read that? 0.04 is 4 with a THS. What does 4 over 100 reduce to?
1/25.
Bingo.
So you have to do.
Yeah. 1/25 equals x. So when I circle it up here, I get 5 to the x equals 1/25. How in the world do you get the 25 on bottom? So 5 to the x equals 5 to the negative second. So just like before, x is negative 2. Anybody? All right, there's some things I need to talk to you about with the graphing here. And there's a good little video that goes along with it. I'll stop it. Even when it is negative, remember we take that number and put it out front. That base right there has to be positive. Just while you get your calculator real quick, do the log of -4. Just hit log -4 in your calculator. Here, remember the base has got to be positive. So when you do log of that number right there, that number is positive. If you make that number negative, it's negative out in front. It's either an exponential growth or an exponential decay. That's the domain. The numbers that you're plugging into the equation are the domain. All real numbers. Domain is all real numbers. Okay, so on our review, I think it says 3 to the x. There's not very much difference between 2 to the x and 3 to the x, except like the answer you can get. And in terms of the path, it's going to look very similar. One that'll be exactly alike is this one right here. And you know what the zero power is? 2 to the third is. So this is an exponential growth. Remember, it's an exponential growth when your base is greater than 0. Greater than 1. When your base is between 0 and 1, that makes it go the other way. If this number right here is a fraction, this thing goes that way. So that question on your that section down there about graphing, when it says about exponential growth or exponential decay, I think it actually asks the question by saying interval of increase. Something is an interval of increase or an interval of decrease. It can't be both. These are not like parabolas. Hello? These are not like cubic equations. Sometimes cubic equations go up and down. These are either exponential growth or exponential. 1/2, 1/4, 1/8. How's your calculator say 1/2? And it's going to get closer and closer and closer to this horizontal line. That horizontal line that it's getting closer and closer and closer to, remember that's called the asymptote. And y equals k. That second section on the final exam review down there, guys, it said you need to put this there. That's y equals k. Your horizontal asymptote is y equals 1 in that first picture. Y is greater than k is your range. Just for fun. Kicks and giggles. Put them all in. Now the range is the picture. The picture of whatever it is that you're drawing is the actual range. That's a picturization of. Y is greater than 0. That's what that says. That's function or interval notation. Y is greater than 0. It's all the same thing.